Welcome back to the Python Praxis. In the first part of Lesson 9, we explored how to convert sequences, copy lists properly, and unleash the power of list comprehensions. Now it's time to raise the bar even higher. In this session, we'll dive into two-dimensional lists, lists inside lists, and see how they let us represent tables, grids, or even small databases right inside Python. We'll also explore multi-dimensional lists, building structures that can model real-world data with precision. By the end, you'll have the skills to work with data in rows and columns, just like in spreadsheets or scientific datasets. So let's get started and give more depth to our Python lists. Let's talk about two-dimensional lists and multi-dimensional lists. What is a two-dimensional list? Simply, it is a list of lists. They are often used to represent tables or matrices. From the first example, we see that each element of the list is another list. In order to access an element in a two-dimensional list, we use the name of the list followed by two indices. The first index refers to the number of the row, and the second index refers to the number of the column, each in separate square brackets. For instance, in our example, we have a list named matrix with two elements. The first element is a list of three integers, 11, 21, and 34. And the second element is another list with three different integers, 14, 35, and 26. When typing print matrix with indices 0 and 1, it prints 21, the element from first row, second column. How can we build two-dimensional lists? We will see this analytically with an example that constructs a two-dimensional list from user input using nested loops. Line 1 prompts the user to type a number for the number of rows. Input returns a string, and int converts that string to an integer. The final integer is stored in variable rows. Line 2 asks the user for the number of columns. Again, converts the string input to an integer and stores it in variable cols. Line 3 initializes an empty list. This will become a two-dimensional list, a list of lists. Line 4 starts a loop that will run once for each row index I. Using range function with rows as argument produces a sequence of numbers from 0 to rows -1. The next line is grid.append, and inside parentheses has square brackets as argument. This creates a new empty list for each row and appends it to grid list. So every iteration appends a new empty list as an element in the grid list. The next line starts an inner loop that runs once for each column index j within the current row with index I. Using range function with cols variable as argument produces a sequence of numbers from 0 to cols -1. Line 7 prompts the user to enter a value for the cell at row I, column j. The f-string format shows coordinates to make it clear which position you're filling. Int function converts the typed string to an integer and stores it in variable value. Line 8 appends that integer to the current row list grid I. After the inner loop finishes for a given I, that row will contain exactly cols integers. After both loops complete, the last line prints the full two-dimensional list. In this segment, we will learn how to modify a two-dimensional list. Think of it as a grid with rows and columns. We'll edit single cells, whole rows, whole columns, add and remove parts. First, let's update a single cell. A two-dimensional list uses two indices, the row index first, then the column index. So to modify a single element, the format is listName, open bracket, row index, close bracket, open bracket, column index, close bracket, equals new value. In the example, we set the value at row 3, column 4 to 45. Next is replacing an entire row. You can replace a whole row in one shot by assigning a new list. The format is listName, open bracket, row index, close bracket, equals a list of values. For instance, matrix 3 equals 2, and inside square brackets, we put 5, 4, and 6. We can also update an entire column. To do that, we loop through the rows and update the same column index each time. The syntax is for each row index r in the list, set the element at row index r, column index call to the new value. To append a new row at the end, the syntax is the listName.append and inside parentheses as argument the new list. For example, matrix.append open parentheses, and inside square brackets we put 5, 4, and 6 and then close the parentheses. In order to insert a new row at a position, the syntax is the list name.insert, and inside parentheses as arguments, we put the index of the position for the new list as the first argument, and the new list itself as the second argument. For example, matrix.insert open parentheses, 3, and inside square brackets we put 5, 4, and 6, and then close the parentheses. To add a column, we visit each row and either append or insert a value. To do that, we loop through the rows. The syntax for appending is, for row in matrix, row.append, and inside parentheses we put as argument the value of the element to append. Here the row is the row index, and matrix is the name of the list. The syntax for inserting is, for row in matrix, row.insert, and inside parentheses we put 2 arguments, the index number of the column to insert and the value of the element to insert. Also here, the row stands for the row index and matrix for the name of the list. Deleting a row is direct. We write the keyword del, followed by the name of the list, and in square brackets we put the index number of the row to be deleted. For deleting a column, we must remove the element at that column index from every row. The syntax is, for row in matrix, del row, and inside square brackets, the column index number. Here the row is the row index, and matrix is the name of the list. In our example, for R in matrix del R3, we'll delete column with index number 3. We can also do bulk updates using list comprehensions like scaling a row or replace negatives in a list. And generally, when you want to transform values in a row or the whole grid, list comprehensions are elegant and fast solution. These are the most common real-world edits you'll make to two-dimensional data. Now let's see an example with step-by-step modifications in a two-dimensional list. We start by creating and initializing a two-dimensional list, named grid, that represents a matrix of 3 rows by 3 columns. Then using a for loop, we print the original list. After that, we change a single cell at row index 0 and column index 2. Next, we replace an entire row, the row with index number 1. The next modification we do is to update an entire column by looping rows. Actually here we loop through the rows and scale the value of the row with column index 0 by 10. Then we append a new row with zeros at the end. Next change is to insert a new row of 2 at position 1, meaning second row. In the following line, we insert a column of -1 at position 1 as the second column. And as last modifications, we will delete certain parts of the list. First, we delete the last column using a for loop and function del with negative indexing. And then we delete the second row using del function. Finally, using another for loop, we print the modified list. There are many cases where we need to make bulk updates in a two-dimensional list. Python with list comprehension allows us to do these tasks easily and in an elegant way. In example 2, we are replacing negatives in a two-dimensional list. By putting the max function with argument 0 and each element from the two-dimensional list inside nested loops for all rows and columns, we replace all negatives with 0 across the whole grid. And this is accomplished with only one line of code. And now something very important. Beware the shallow copy trap when creating two-dimensional lists. Avoid duplicating the same inner list with the star operator. It makes every row point to the same list in memory. We will explain this issue in example 3. The wrong version is, we create a list called bad using the star operator. Here all rows reference the same inner list. And when we try change the first element in the first row, we actually change every first element in all rows. The correct version is, we create a list called good using 2 nested for loops to put 0 in every element of every row. This way we have independent rows, and when we change the first element in the first row, only one cell changes. Now it is time for an exercise with a two-dimensional list. Create a 4x3 matrix and initialize it with numbers of your choice. Then, add a row with numbers at the end that start from 0 and increase by 2 per column. Print the new 5x3 matrix. Add a column of 2s at the start, and print the final 5x4 matrix. Let's see the code step by step. In line 1, we create our starting matrix. It's a list of lists, 4 rows, each with 3 columns. This is our 4x3 table. In line 2, we generate the row we want to add. This is a list comprehension. Range 3 gives 0, 1, 2. We multiply each by 2, producing 0, 2, and 4. That's exactly the pattern the exercise asks for. Start at 0, increase by 2 per column. In line 3, we attach that new row to the bottom of the matrix using append. Our shape is now 5 rows by 3 columns. In line 4, we print a friendly label so the output is easy to read. The loop in lines 5 to 6 prints each row on its own line. It helps us visually confirm the matrix is now 5 rows tall. Lines 7 and 8 add a new first column. We loop through every row, and for each row we insert the number 2 at position 0. In list terms, position 0 means the very beginning. Doing this for all rows creates a brand new leftmost column of 2s. Our shape is now 5x4. In line 9, we print another label. We also add a blank line for clarity. Finally, lines 10 and 11 print the finished matrix row by row, so you can verify the new column is in place. So to recap, we started with a 4x3 matrix, used a list comprehension to generate the 0, 2, 4 row, appended it to get 5x3, and then inserted a 2 at the start of every row to add a new first column, ending with a 5x4 matrix. Along the way, we practiced two-dimensional list creation, list comprehension, append, insert, and simple iteration. Nice work! Knowing what is a two-dimensional list and how we can create or modify one, we can also create and handle a list with 3, 4, or more dimensions depending on our needs. A multi-dimensional list is just a list whose elements are themselves lists, possibly nested several levels deep. Two-dimensional list is a table with rows and columns. Three-dimensional list is a stack of tables with layers, where each layer has rows and columns, and so on for more dimensions. They can be constructed in a similar way as two-dimensional lists. Pick consistent names per axis so you do not get lost. For example, for a 3D list, use L for the number of layers, R for the number of rows, and C for the number of columns. In the example, using list comprehension, we create a 3D list with 2 layers, 3 rows, and 4 columns initialized with all elements 0. And that brings us to the end of Lesson 9, Advanced Topics in Lists. We've mastered conversions, copying techniques, list comprehensions, and finally two-dimensional and multi-dimensional lists. With these tools, you're now equipped to tackle much more complex data structures, the kind you'll encounter in real-world projects, from data science to game design. Keep experimenting, keep practicing, and let every new list you build take you one step closer to Python mastery. In the next lesson, we'll push forward into new Python territory and expand your toolkit even further. Until then, happy coding!